Let's go over one more example. So here it says, write a program that sets all values greater than the average value in a matrix to 0 and all values less than the average value in a matrix to 1. So key thing is here we're talking about values in a matrix. So values in a matrix. If statements and branching statements work on scalars. So if you say if a question here, this needs to be a single answer. It's called a scalar. So if we're doing values in a matrix, we can't do an if statement. That's okay. We can do something called logical indexing. Where what happens if we just say a matrix, so A, and if we ask a question regarding that matrix, so A greater than 0, here's our question. What that's going to do is it's going to isolate all values in A that are greater than 0. So we don't even need an if statement. We can just say right away, I want to grab all the values in A greater than 0. I can just use logical indexing in order to, looking like this, in order to ask a question directly for a matrix, and it will isolate all those values. Okay, so let's go ahead and start looking at how this looks in MATLAB. So here I have a matrix, a random matrix with values from 1 to 100, 5 by 5. Okay, so my question says I need to set all values greater than the average value in the matrix to 0. So I need to go ahead and figure out the average value. So average equals the mean function A in the colon. So this means grab all of the values in A and calculate the average between them. One thing to mention is the mean function works column-wise or row-wise. Another thing we could do is say mean all. And that will give us the mean value in our matrix. So here for this matrix here, the average value is 52.16, 0.16. Okay, so I've got my average value. Now I want to go ahead and set all of my values in my A matrix that are greater than the average to 0. So once again, I can't just ask a scalar and say A greater than average. I can't do that. That is not going to be a single number, so I can't use an if statement. However, if I do this, it will give me a bunch of answers. So it will give me a bunch of answers. This is called a logical array. It's full of ones and zeros. A 1 is wherever that answer is true. A 0 is wherever that answer is false. So this will give me a bunch of answers. So this here is a whole matrix of answers. So I can't use an if statement because it gives me a matrix of answers, but I can do logical indexing. So I can say A, and then ask the question directly to A. So A greater than ABG. So we already know that this is a whole matrix of answers. So what this is going to do is this is going to give me all of the numbers where my answers are equal to 1. So if we make this a little bit bigger over here on the side, here's my original A matrix. So there's a 1 here. 53 is greater than my average, so it's going to give me 53. Then it's going to go to the 0. Okay, there's a 0 here. It's going to ignore the 15. There's a 1 here. It's going to grab the 81. So 81. There's a 0 here, 0 here, 0 here. There's a 1 here. It grabs the 66. 0, 0, 0. 1, it grabs the 82. 0, 0, 0. 1, it grabs the 53. 1, 1, 1, 1. Grabs all those numbers. 0, 1, 1, 0, 1, 1. So we can see it grabs all of the numbers in A where A was greater than the average. So if we want all of those numbers, we can just do that directly. I don't want all of those numbers. I want to set them all equal to 0. Okay, so remember back in week 2, week 3, whatever it was, where we have where we want to store something equals what we want to store there. So I want to store a 0 wherever A is greater than the average. So here I run this. Here's my new A matrix. It's randomly generated every time. Here's my new A matrix. Here's my average. It puts a 0 wherever the A is greater than the average. So with one line of code, I've replaced all of these numbers with a 0. So if I want to go ahead and do the second part that says all the values less than the average value in a matrix to 1, I can say A less than the average equal to 1. Run it again. Whoops. So notice it gave me all of those numbers directly. I would put this in a new matrix, so I can say, here we go, n equals zeros size A. So then n is going to be 0 wherever the A matrix is greater than the average, and 1 wherever the A matrix is less than the average. So here we go. So there we go. So AR started as zeros, and here's a 1 placed, or n already started out as zeros, but I did put the zeros there with this line of code, and then I replaced all of the locations where A is greater or less than the average with a 1. Keep in mind, in order for this to happen, n and A need to be the same size. Okay, so just keep that in mind. So then I can go ahead and change. So then the next part of my problem, so this part, change it so that the value is greater than 75% of the average to 0 and less than 25% of the average to 1. So I'm going to do S for my second matrix. I'm going to set S equal to A right away, so we maintain all of the A values. Then I can go ahead and change parts of S. So in S, wherever A is greater than 75%, so 0.75 of my average, wherever it's that, I want that to be set equal to 0. And wherever in S, whenever A is less than 0.25 times my average, I want to set that equal to 1. So here's my A, here's my new average. I've replaced all of the numbers greater than 75% of my average to 0, and all the numbers that are less than 25% of my average to 1. And you can play around with the numbers if you want, but that's essentially how we would do something. So now instead of it being specific rows and specific columns, now I can do what's called logical indexing, where I can ask a question and say wherever something is greater than something. And you can combine questions as well. So you can combine questions to say greater than 75% of the average, or A less than 0.25% of the average. So now if you're only looking for a specific range, so you can go ahead and do that. Keep in mind, if you're dealing with arrays, you can only use a single bar or a single ampersand. So here we can see that it replaced all of the values that fit this description equal to 0. So if you're dealing with arrays, you can't use if statements. If statements work on a single answer, one answer total. So if you're dealing with arrays, we can do logical indexing, where we can ask our question directly to a matrix. So change the values in S wherever it fits this description. Keep in mind, the numbers on this side need to match the numbers on this side. With a scalar, it's just copied over. But you can have a question on both sides, just make sure they match up. And there we go. That is logical indexing. So hopefully that helps for your homework, and you'll be able to do all of it wonderfully.